um, how to undo the chat if you don't want to be bothered by the chat. So, but that's our place. So, all right.
All right. Well, thank you, Glenn, and thank you, Matthew. Thank you, everybody. This is terrific. I mean, I'm looking at the participant list here, and well over 330 people, which is terrific. I'm sorry I can't be in California with y'all, but that's the nice thing about Zoom. I'm actually coming to you from New Hampshire this evening, where it actually feels weirdly like spring. It hasn't been much of a winter here in the Northeast, except for that little couple of days where it got down to like 44 below zero wind chills 2 weeks ago. And the migration wave hasn't really started to hit New England, but I know just a little farther south of us here in the East, we're seeing a fair bit of spring migration occurring already. So I'd like to talk about migration this evening. And so I'm gonna do the little screen share shuffle here, which as we were saying before the webinar started, is always a little bit awkward. So bear with me for just a second here. While we do that. And Glenn, tell me if you're not seeing a title slide, but otherwise I'm going to assume that, that you can see all these. Super. Okay, so you see all those sandhill cranes on the Platte River in Nebraska.
Yes.
One of my favorite places on earth. So yeah, we'll talk about migration. I am kind of obsessed with migration. I've been obsessed with migration now it was 51 years last fall since I got hooked on migration in a serious way. I grew up in the mountains of eastern Pennsylvania, not all that far from Hawk Mountain Sanctuary. And on one particular day when I was 12 years old, my first trip to Hawk Mountain was just like by dumb luck, the most astounding migration day of the fall, strong north wind, hawks, eagles, and falcons pouring down the ridge, coming from as far away as Greenland and heading to Bolivia and Argentina. It blew my 12-year-old mind. And so for, a half a century plus since then, migration, I think, has really been kind of the defining passion of both my personal and professional lives. Back in the mid-90s, I set everything else aside for about 6 years and followed bird migration up and down the Western Hemisphere for a book called Living on the Wind, about bird migration in the Americas. And I wrote this very much as an outsider looking in. I don't have an academic degree in science, which is kind of weird because I'm a fellow of the American Ornithological Society these days. But ornithology has always been one branch of science, kind of like astronomy, that's been very welcoming of passionate, committed outsiders. Starting in the 1980s, I began doing a lot of serious bird banding, working with Hawk Mountain's research crew, banding hawks and eagles and falcons, doing radio telemetry. That morphed into working with several species of owls and banding hummingbirds and passerines, and getting deeper and deeper into the trenches in migration science over the last 25 or 30 years. And during that time, since Living on the Wind came out in 1999, our understanding of bird migration has gotten much deeper. Our understanding of the mechanics of migration, the physiology of migration, and also the challenges that migratory birds face around the world. And so about 6 or 7 years ago, I headed out at a global scale this time, writing about what we've learned in the last quarter century about migration, the new mysteries that we've uncovered about migration, and the challenges that are facing migratory birds around the world. And I think it will not come as a surprise to anybody who's listening this evening that migratory birds are in crisis. Most of you, I'm sure, are aware of this paper that was published in the journal Science 3 years ago, documenting the fact that we've lost a third of North America's avifauna, about 2.9 billion fewer birds today than there were 50 years ago, basically since the time I was that wide-eyed 12-year-old. And I don't want to start out this evening with a buzzkill, but I think it's important for us to understand what the odds are. And I promise this is also the only graph I'm going to show you this evening, because unless you're a scientist, graphs can be kind of boring. But this is from that science paper, and it shows how the different habitat groups, the different habitat guilds of birds in North America have fared over the last half century. birds of the eastern forest, birds of the Arctic tundra, western forest birds, and so forth. And the group of birds, not surprisingly, that has fared most poorly in the last half century are grassland birds. Birds like western meadowlarks, bobolinks, upland sandpipers, LeConte sparrows. And look, the reason for this is not a mystery to anybody. We've destroyed most of our natural grasslands in this country. We've plowed them and grazed them and Walmarted them and housing developed them pretty much out of existence. But if you look at the other end of that chart, the other end of that graph, there's maybe a reason for hope and perhaps a roadmap for recovery. Because look at what's happened over the last half century to wetland birds, to waterfowl like ducks and geese and swans, to cranes, to wading birds like herons and egrets and ibis. Their numbers have rebounded dramatically in the last 50 years. And here again, the reason for this is not a mystery. Starting in the 1980s, when waterfowl populations in North America cratered because of a combination of habitat loss and prolonged drought, we as a society began pouring an enormous amount of time and muscle and regulation and resources into restoring and protecting wetland habitats. And it ain't just baseball players. If you build it, they will come. And so I'm not saying that the only problem with grassland birds like these greater prairie chickens is habitat loss. There's other issues as well, including our grievous overuse of pesticides in this country. But it is fundamentally a habitat problem. And if we as a society put the same amount of energy and time and resources and regulatory muscle into protecting and restoring grassland habitats as we did wetland habitats, we could make an enormous difference for the group of birds in North America that is in the deepest trouble. The environmental headlines are so bleak. It's just such a drumbeat of bad news. It's easy to give up and despair, and it's easy to lose sight of the fact that all around the world, conservationists are confronting the challenges facing migratory birds. And in many cases, against pretty steep odds, they're making progress. I am cautiously optimistic about the future of migratory birds, in part because we have so much more information than we had even just 5 years ago. It's astonishing the leaps we've made in understanding where and how migration is occurring, the threats that are facing migratory birds at different points in their migration. And a lot of that comes down to our newfound ability to really master big data, huge data sets, like Doppler weather radar information from the Doppler weather system that shows us in astonishing detail exactly how many birds are migrating through the night skies over the lower 48. Observational databases like eBird that show us with remarkable detail where and in what numbers and in what densities and at exactly what times of the year birds are moving across not just North America, but increasingly around the world. And we're also tapping into the use of increasingly sophisticated and increasingly miniaturized tracking technology that is allowing us to peer into the lives of these birds in some cases on a second-by-second basis. And this is an aspect of migration research that I've really been involved pretty deeply in over the last 25 years, using a lot of these new groundbreaking technologies as they emerge, like geolocation and hyper miniaturized VHF radio transmitters. And we're going to talk a little bit more about that as we get into this. And last but not least, we're also continually amazed by what we're learning about the sheer physical abilities of migratory birds. Some of this stuff seems like it's ripped more out of the pages of a science fiction book than out of a natural history book. What the physiological abilities of migratory birds are absolutely astounding. And even the smallest migratory birds do incredible things. I mean, in terms of migration endurance, we know that shorebirds are among the greatest of all long-distance migrants. And in terms of land birds, shorebirds like bar-tailed godwits flying, 11 days across the widest part of the Pacific Ocean from Alaska to the North Island of New Zealand or the coast of Australia is just absolutely beggars belief. But even small migratory shorebirds do amazing things. Like semi-palmated sandpipers like this one, 6 inches or so long, they weigh maybe a little bit less than an ounce. And yet the semi-palmated sandpiper population that breeds in the eastern and central Canadian Arctic takes off from the northeastern coast of North America and flies out over the Western Atlantic, 3,300 miles nonstop, a journey of 4 or 5 days, to their wintering grounds on the northeastern coast of South America. That's the equivalent of a human being running 126 consecutive marathons and doing it without food or water or rest. And in fact, speaking of marathons, I have very limited patience with people who start comparing birds to human athletes, because I'm sorry, the humans just don't rate. They don't rate. For example, you could argue that the human athletes that are at the peak condition, the most elite human athlete, is a Tour de France cyclist at top condition. This is somebody who is operating at 4 or 5 times his base metabolic rate, and really only able to do that for a relatively short period of time, certainly less than a day, and only with regular food and regular hydration. On the other hand, that little semi-palm sandpiper at rest has a higher metabolic rate than a person. Its body temperature is about 104 degrees Fahrenheit. And when it's flying 4 or 5 days nonstop across the Western Atlantic, it's operating at 9 or 10 times its base metabolic rate. And again, doing that with no food or water or rest. But there is one way in which the semi-palmated sandpipers coming out of the Eastern Canadian Arctic are similar to at least some human athletes. So these birds in the fall often stage up in large numbers around the Bay of Fundy between Nova Scotia and New Brunswick and the coast of Maine. And of course, the Bay of Fundy is famous because it has this enormous tidal range of 30 or 40 feet. And when the tide goes out, it exposes enormous areas of mud. And in that mud are tiny little crustaceans known as corophium. And we know from observation that the semi-palmated sandpipers preferentially feed on the corophium. They seek them out and hunt them specifically, among all the other multitude of small invertebrates that are found out there. Now, I have never tried corophium. Maybe they taste really good, but we do know that the corophium are really high in omega-3 fatty acids. And those fatty acids supercharge the aerobic capacity of the bird's flight muscles. Basically, what they're doing is juicing on performance-enhancing drugs. The difference is what they're doing, compared to some Tour de France cyclists who shall remain unnamed, is legal and ethical. We're also discovering amazing new things about how birds are able to orient and navigate as they're migrating. We've known for a long time that one of the most important migratory cues, orientation cues for migratory birds, is the night sky. Most birds migrate at night, even those like most of our songbirds that are normally active in the daytime. The night sky is cooler, it's calmer, it's less turbulent, there are fewer predators, and you have this terrific roadmap overhead. Now, it's not that they're looking at the pattern of the stars. They're not looking up and going, okay, the giant W is Cassiopeia, so that means I make a left. They're aware of the apparent rotation of the stars, how they seem to wheel around the one part of the night sky that does not move, which of course is Polaris. And that gives them their compass points, north, south, east, and west. Of course, that only works if the sky is clear. But birds have a whole host of fallbacks that they can use if the sky is cloudy. For example, seabirds can smell their way back home across thousands of kilometers of ocean, back to a single nest burrow among millions of other nest burrows in the pitch black. Diurnal migrants like swallows and hawks use the position and movement of the sun across the sky. And there's a band of polarized light about 90 degrees off the sun that they can see that is harder for us to see. Birds can use extremely low frequency sound waves, infrasound, that can travel for hundreds or thousands of miles. But the most mysterious of all of a bird's migratory cues has always been their magnetic sense. We've known since at least the middle of the 19th century that birds somehow could sense the Earth's magnetic field. When I was in college in the 1970s, I took a terrific course in ornithology from a fantastic professor, we were taught that birds had these tiny little deposits of magnetic iron crystals, magnetite crystals, in their brain or at the base of the bill. And the assumption was that this basically functioned like kind of like a compass, kind of pulled their nose to the north. Well, it turns out that those structures in the brain and the base of the bill are not magnetite. It would appear that they are part, perhaps, of the bird's immune system. They certainly have nothing to do with navigation. It turns out the way that birds are able to sense the Earth's magnetic field is part of it comes out of a bizarre form of quantum physics that was so strange that even though it grew out of his own equations, Albert Einstein more or less disowned it. He called it spooky action at a distance. We know it as quantum entanglement or radical pair theory. And I'm going to try to explain this, but you need to understand that I am not a quantum physicist. So you're getting a layman's understanding of this. But let's say that you are a summer tanager like this one, taken off from the Yucatan Peninsula. You're flying north toward the Gulf Coast of the United States through the night sky over the Gulf of Mexico. And a photon of blue light that was emitted from a star 10 million light years away enters your eye and it strikes your retina. And it hits in that retina, it hits a protein pigment called cryptochrome. And there's a lot of cryptochrome in the eyes of migratory birds. And so this photon enters the cryptochrome, it knocks an electron off one molecule in the cryptochrome into an adjacent molecule. So those molecules now have an unequal number of electrons. They are in quantums, under quantum theory, they are now entangled. They are essentially one thing. And under quantum theory, if you moved those two molecules anywhere in the universe, what affects one would instantaneously affect the other. It is weird. Don't expect me to be able to explain to you why, but according to quantum theory, that's how it works. We are told that this will eventually produce unhackable quantum computers and faster than light communication. But what it also does in the eye of the bird is it briefly magnetizes that pigment, that cryptochrome pigment in the eye. So you have these magnetically sensitive pigment proteins in the eye of the bird. And what appears to happen as the bird is flying north through the night sky is it's able to see the waves of electromagnetic radiation that emerge from the surface of the Earth, and whose angle as they emerge from the surface of the Earth changes as you go closer to or farther away from the equator. You know what I would give to see the Earth's magnetic field? I just, in my mind's eye, I assume it must be like more amazing than the aurora borealis. We don't actually know how the birds visualize it. We just know experimentally that they can. And they all seem to be able to do it. This seems to be a fairly universal among any birds that have been tested. My guess is that every yellow-rumped warbler and house wren and, I don't know, maybe house sparrow that's flitting around out there can see this, and we can't. And in fact, every time we think we understand what the limits of bird migration are, the birds kind of blow right past them. For example, this is an alpine swift, not a bird you're going to see in the Bay Area. They breed in Central and Western Europe. And about 10 years ago, scientists in Switzerland were curious about where alpine swifts go for the winter. They knew they wintered somewhere in Western Africa, but they didn't know what routes they took. They didn't know where exactly they were spending the winter. So they captured these birds. They fitted them with little backpack harnesses, on the back of which was a data logger. And in that data logger, there was a geolocator, which would record the bird's location, at least roughly, over the course of the next 9 or 10 months while the bird was gone. And also a little accelerometer in there that would measure the movement of the bird, be able to tell how much of the bird's day was spent at rest, how much of the bird's day was spent in active flight. They had that information for the breeding grounds. They were interested in getting that for migration in the winter. So they fit these birds with these little gizmos. They send them off. They fly away for the winter. They come back the next spring, because these aren't transmitters. You have to recapture the bird and then download the data. So they recapture them, they download the data, and they say, oh, look at that. The birds flew across the Sahara down into the bulge of tropical West Africa, came back the next spring. Some of them came across the Strait of Gibraltar and up through the Iberian Peninsula. And then they looked at the accelerometer data. And that's when their jaws hit the floor. Because according to the accelerometer data, these birds never stopped flying for 7 months. From the time they left Switzerland, all the way south on their southern migration, through the entirety of their winter season in Africa, and all the way back in the spring, they were in constant, perpetual powered flight. Now, look, swifts are the most aerial of all birds. They eat nothing but flying insects. Swifts are the only birds in the world that mate on the wing, but come on, 7 months without landing? 7 months without resting your wings? That seemed extraordinary. And yet, 2 years later, when scientists in Sweden did the same thing, the same experiment with common swifts, they found that they spend 10 months of the year in constant flight. And until recently, we thought maybe this was something that only old world swifts did. But just last year, scientists published a paper showing that black swifts that breed in Western North America and winter in South America do basically the same thing. It appears that wherever you are as a swift, You don't land unless you absolutely have to. Now, most migratory birds do not spend months on the wing. Oh, and I should also say the reason that they're able to do that without dying from sleep deprivation is they undergo something called unihemispheric sleep, where they basically put half their brain to sleep for anywhere from a couple of seconds to a couple of minutes at a time, and they just bounce consciousness back and forth between one side of their brain to the other, as one does. Like I said, most migratory birds are not in the air for those astounding lengths of time, but the migrations, especially of long distance migratory shorebirds, really are remarkable. These are birds that are crossing thousands, sometimes tens of thousands of miles of utterly inhospitable terrain like wide oceans, where if they pause along the way, they're dead. And so the only way they can make these trips is by having really rich resources before they leave, really rich resources at key stopover points along the way, and at the final point of their migration, either on their wintering grounds or their breeding grounds. And the greatest of all of those migratory systems and the greatest of all of the world's migratory stopovers, arguably, is what's known as the East Asian Australasian flyway. This is an enormous area of Eurasia, Asia, Oceania, Australia, all the way down to New Zealand. And the birds that winter in the southern hemisphere breed from, as you can see there, from central Eurasia all the way into Alaska and the Yukon. You have birds that are, like, for example, the bar-tailed godwits coming from Alaska that have flown across the Pacific Ocean. On their spring migration, they'll fly 6,000 miles nonstop from New Zealand and the coast of Australia all the way to the Yellow Sea between China and the Korean Peninsula. The Yellow Sea is the linchpin in this enormous global migratory system. And what draws them, the shorebirds, to the Yellow Sea are the largest mudflats on Earth. These mudflats put the Bay of Fundy to shame. This is a picture of Chaoxini on the Chinese coast north of Shanghai. And when the tide goes out here, it goes out like 20 kilometers. It is an astoundingly large expanse of mud. Kind of lifeless when you look at it on the surface, but underneath the surface, it's full of macroinvertebrates and anneliid worms and small mollusks and all kinds of great things for birds that have just flown 6,000 miles, arrived on the ragged edge of starvation, have to double their weight in less than 2 weeks, and then fly another 4,000 or 5,000 miles to their breeding grounds in the Arctic. The problem is there are far fewer of those mudflats than there were even just a couple of decades ago. China and South Korea in particular have destroyed about 60 or 70% of the mudflats on their portions of the Yellow Sea. They build these enormous seawalls and then fill in what had been rich intertidal land in the inside of the seawall. They fill it with hundreds of millions of cubic meters of sediment to create either dry land for cities or industrial sites, or deep water aquaculture ponds for fish and jellyfish and shrimp that are too deep for the shorebirds to use. And when I traveled over to China in the spring of 2018 to report this portion of A World on the Wing, I'd spent time with scientists like Xing Li and Dr. Tunis Piersma from the Netherlands who've been studying these birds for years. And Tunis told me, look, we are basically at a birds per hectare equation. For every additional acre of mudflat we lose birds because they simply have no other place to go. They've been squeezed as far as they can go. And in fact, a couple of years ago, when South Korea built a 21-mile-long seawall that blocked the ocean from 150 square miles of formerly rich tidal flat, on which about a quarter of the world's great knots depended, a quarter of the world's great knots disappeared. They had no other place to go, and that was the end of them. Now, chances are, if you've heard about the Yellow Sea, it is because of this bird, the spoon-billed sandpiper, the world's weirdest and most weirdly charismatic shorebird, the only shorebird with that bizarre spatulate bill, and one of the rarest, not just rarest shorebirds, but one of the rarest birds of any sort worldwide. Only a couple hundred of them left. They breed in the Russian Far East, they winter in Southeast Asia, and they depend utterly and completely every year on the tidal flats of the Yellow Sea, particularly on the Chinese side. And because they're so rare, and because they're so well known, birders around the world know them as spoonies. They've become, as I said, the poster child for Yellow Sea conservation. And so conservationists like Xing Li, who founded spoon-billed sandpiper in China to lobby for the protection of what remains of the Yellow Sea's tidal flats, organizations internationally like BirdLife International, The Paulson Institute, founded by former Treasury Secretary Hank Paulson, all of them pushing very hard over the years for the Chinese government to step in and save what remained of the Yellow Sea mudflats. And the astounding thing is it worked. Just a few months before my visit to China in 2018, the Chinese government, kind of out of the blue, announced a near total ban on further coastal destruction for commercial purposes along the Chinese portion of the Yellow Sea. Over the next couple of years, they nominated about 24 of the most important shorebird sites, including some of the ones you've seen here in some of these pictures, for UNESCO World Heritage protection through the UN. South Korea followed suit with nominating 4 or 5 of its most important sites within the last couple of years. They've been a little bit slower off the mark. But it was interesting. I went to China expecting to write the most depressing chapter of my book. And instead, I found myself with people hanging out with people like Jing while they were grappling with this extremely unfamiliar emotion, which was hope. And yet it's not just coastal destruction that's driving the declines in these birds and posing threats for them. Across much of Asia, illegal bird trapping and bird poaching is a huge problem. That remains the single biggest threat remaining for spoonbill sandpipers, people shooting them or netting them or trapping them for the pot. And it's not just a problem in Asia, although the problem is obviously a greater magnitude in Asia. For example, for birds like this female Eurasian blackcap that migrate around or across the Mediterranean basin, it is a fraught journey. Tens of millions of birds killed illegally for the pot every year around the Mediterranean. And the numbers are really kind of staggering. For example, about 5.5 million birds killed every year illegally in Egypt, about 2.5 million in Lebanon, about 4 million in Syria. Now, admittedly, there is not a lot of wildlife law enforcement going on in Egypt or Syria or Lebanon these days. But this is not a problem simply of politically troubled, politically unstable parts of the world. For example, every year, about 500,000 migratory songbirds, song thrushes, missel thrushes, endangered ortolan buntings, are killed illegally in France. It's against French law, it's against EU regulation. And I want to make clear, this is not people putting food on the table for their starving kids. These are well-to-do people who like to eat songbirds because that's something they've been doing for a long time there, and they're not going to let the declining fortunes of these birds or the fact that it's against the law stop them from doing it. And in fact, the most, really arguably the most dangerous place to be a migratory bird in the entire Mediterranean basin is good old civilized Italy. About 5.6 million songbirds killed every year for food, for traditional foods that people are eating because they like it, not because they need to, in Italy. But that's basically a law enforcement problem. And there's been a lot of pressure being brought to bear on illegal bird trapping in the Mediterranean basin. The island of Cyprus used to be known as the black hole of bird poaching in the Mediterranean. As many as 10 million songbirds a year killed in an island about the size of Connecticut. But thanks to increased law enforcement, that number has dropped precipitously. You throw enough resources at it, you can make a difference with illegal bird killing. Of all the problems facing migratory birds, I wish they could all be that easily confronted. There's no doubt that the big enchilada is climate change. That's the biggest challenge facing migratory birds, and it's going to be the hardest nut for us to crack. I have gotten to the point now where if somebody tells me they don't believe in climate change, I tell them I don't care. Doesn't matter what they think. The climate is changing. Any idiot can see that. Certainly the birds can see that. They can see the fact that the seasons are changing drastically. The phenology, the timing of the seasons is changing. And you can see that if you look at the data, and there's a few places around the country where there are long-term data sets, like, for example, Mohunk House in upstate New York, where people have been keeping meticulous records of the weather, the climate, the first emergent dates for tree leaves, bloom dates for wildflowers, the first arrival dates for many species of songbirds. And you can see that spring is galloping ahead weeks and weeks earlier than it was 50 or 60 years ago. And you can also see that quite a number of birds are arriving earlier in the spring than they did just a few decades ago. which is a comforting thought that you can have, a degree of plasticity, a degree of adaptability on the part of these birds. But before we get too comfortable with that, if you dig a little bit deeper into those long-term data sets like the one at Mohawk House, you realize the birds that are coming back significantly earlier than they were half a century ago are birds that for the most part winter in the southern United States, maybe into northern Mexico. Birds like fox sparrow, eastern phoebe, bluebirds, eastern towhee, brown thrasher. If you're a fox sparrow sitting in a backyard in Georgia, you can tell whether it is an unusually cold late winter with north winds day after day after day, in which case you're just going to sit there a little bit longer and wait it out. Or if it's a year like this one, where spring is like 3 or 4 weeks early in the American Southeast, where it's warm winds day after day after day coming out of the south, you're going to catch those south winds, you're going to catch those tailwinds and head north a bit early. When you look at the arrival times, the average arrival times for long distance migrants, like our neotropical migrant songbirds, like black-throated green warblers coming back to the forests of upstate New York, these birds are basically coming back more or less on the same schedule they did a century ago. There's been a number of studies published in the last couple of years looking at banding data and other data sources to show that, these birds may be coming back, 5, 6, 7, 8 days earlier than they did 60 years ago, but spring is leaving them in the dust. And, just within the last couple of months, Morgan Tingley and his lab at University of Southern California, I believe, Morgan, if you're out there, I hope I didn't get that wrong. They were able to show that there's not a mismatch in the seasons, not just on the timing when these species as a whole are coming back, but the males are actually coming back earlier than the females and the juveniles. So you have this increasing mismatch between the migration and the seasons, and an increasing mismatch between the resources that these birds need and the timing when they come back. We've seen in other parts of the world, with species like Eurasian pied flycatchers, what can happen if these birds get so far out of sync with the seasons that their populations actually can collapse rapidly. We haven't seen that among North American songbirds yet, possibly because our birds don't have to travel quite as far as, for example, the Palearctic migrants that breed in Europe and winter in tropical Africa, and then they cross the Sahara and the Mediterranean Sea to get back. Ours have a shorter distance to fly. Our forests are somewhat richer and more diverse in insect life, so there isn't a real sharp seasonal peak in insects, more of a broad plateau, but nevertheless, climate can cause real problems for migratory birds. And those problems can come from the fact that, it's not just global warming. It's not like everything's getting evenly warm everywhere. Some places are warming dramatically faster than others, like the Arctic. But even there, some places at certain times of the year are actually getting colder. And weirdly, the eastern and central Canadian Arctic is one of those places, an area that's of profound importance for migratory shorebirds like this red-necked phalarope, migratory waterfowl. In that part of the Canadian Arctic, late winter and early spring are dramatically colder and snowier than they were just 5 or 6 decades ago. And midsummer is dramatically hotter. So you have birds like these phalaropes that winter off the Pacific coast of South America, coming back across 7,000 or 8,000 miles. Hudsonian godwits coming back from the southern tip of South America. They fly 9,000 miles to get back to a place like Hudson Bay and Cape Churchill, and they arrive and everything's frozen solid. I mean, they're arriving on schedule, but the season is late. So they have to wait, and then finally everything melts and they can build their nest and lay their eggs and incubate them, and the chicks hatch, and bam, it's like this climactic switch gets flipped. And now it's gone from unusually cold to unusually hot. And the insects in those Arctic pools, the mosquitoes and midges and all the other things that those baby shorebirds are going to have to be able to catch for themselves when they hatch. Because remember, shorebird babies, waterfowl babies, they feed themselves. Mom and dad don't bring food to them. Well, those insects are exquisitely sensitive to the temperature, and that unusually warm summer temperatures mean that they hatch earlier. So the birds are breeding later, the insects are emerging earlier. What happens increasingly is that by the time the chicks reach their hungriest and most energy dependent, the insect peak is passed for the season. And increasingly, most of those chicks don't survive. And so many years, for example, Hudsonian godwits, maybe only 5 or 6% of their chicks are going to make it to adulthood. We've known for a long time that migration is the most dangerous part of a bird's annual cycle. It's also the part of a bird's annual cycle about which we know the least. It's a black box. These birds are migrating at night. It's really hard to see them. I mean, you can watch the face of a full moon with a pair of binoculars or a spotting scope and see birds fly across the disk, which is cool, but that doesn't give you a whole lot of information. But maybe just in the nick of time, in the last couple of years, we've gotten the computing power and the ability to start to use really huge data sets to unlock that black box, to see what's going on in real time with migration, to understand where the birds are, in what numbers, and perhaps what threats are facing them at different points in their life cycle. And ironically, one of the most important tools for understanding bird migration is the North American Doppler weather radar system, which I can guarantee you the National Weather Service did not build with the idea of it being in service of ornithology. But in addition to showing us snowflakes and ice crystals and raindrops, all of those 140 some Doppler weather sites at usually at metropolitan airports across the country can tell us with exquisite precision how many birds per cubic meter of airspace are flying through the night sky overhead. And we now have enough computing power that the Cornell Lab of Ornithology can take all of that radar data in real time and produce these terrific birdcast maps during the spring and fall migration. And if you haven't played around with birdcast, I encourage you to do so. They're able to tell us in real time how many birds are flying over the lower 48. What you're seeing here, that red line moving across the continent, is sunset. And so you're seeing this explosion of birds in flight. This is an animation from May 15th of 2021 on a night when there were almost 750 million birds moving across the lower 48. And because we have archived weather radar data that goes back decades, we basically have a time machine, because we now have enough computing power to crunch all of that data and see exactly how and where and to what extent migration has changed in different parts of the country from week to week, month to month, decade to decade. In fact, a lot of the precision in that 2.9 billion birds gone paper that I talked about earlier came from radar. They weren't just pulling a number out of their hat. So radar can tell you how many birds are up there, but it can't tell you what kind they are. It is, in the words of Andrew Farnsworth at the Cornell Lab that works with radar all the time, it's taxonomically agnostic. In order to paint in that detail, you need another big data set. And of course, that is eBird. I would imagine eBird doesn't need a lot of an introduction to this crowd, but in case you've never heard of it, eBird is the world's largest wildlife observational database. Every year, birders around the world contribute about 100 million new sightings to eBird, and it's allowing us to see where birds are when in just extraordinary detail. So what you see here is an animation map showing the movements and densities of yellow warblers, one of the most widespread neotropical migrants in North America, as they move up out of their wintering grounds in Central and Northern South America, spread across North America in their breeding grounds, and then coming back south again. This is giving us information that we didn't have before, and combining with radar data and other things, we can see where the birds are. We can see what habitats they're using. We can see what land, if I were concerned about yellow warbler conservation, I mean, it's obviously one of the more common species, but as these birds start to move south here in a moment, watch what happens to Louisiana. Watch the way, look at how dark Louisiana is. The oak cheniers of coastal Louisiana are incredibly important for yellow warblers. And eBird's been out there long enough now that we've been able to, the folks at Cornell Lab have been able to start to produce these really terrific trend maps that they just rolled out a couple of months ago for hundreds of species of North American birds, showing, at a scale of about 30 kilometers, where these birds are doing well and where these birds are not. So this is a trend map from 2007 to 2021 for red-tailed hawks. And you can see that across much of eastern and central North America, red-tailed hawk numbers are in fairly minor decline, pretty serious decline in parts of my old stomping grounds in my home state of Pennsylvania and in parts of coastal New England, but they're doing quite well in many parts of the West. The darker the the color, the better or worse they're doing, depending whether it's blue or red. If you've not had a chance to explore eBird recently, go under the Science tab that you can see there at the top and click on Status and Trends. I think you will be surprised and in some cases kind of shocked to see what's going on with even some of the most common species of birds. But all of this is giving us information we didn't have before and pointing us in directions where we can make a difference for these birds. For example, both eBird and radar are showing us the degree to which we did not understand how urban light pollution is affecting bird migration, and particularly young birds, young naive birds on their first migration in the fall. It's drawing them like moths to a flame into urban areas and into the dangers of urban areas. You know, we lose something like 1/3 of a billion birds every year with skyscraper collisions in metropolitan areas. You know, they're pulled in there, but it gives us at least two ways that we can turn things around for birds. For one thing, we can just get people to turn off their lights. And I've really been encouraged in recent years how many metropolitan areas across North America have instituted lights out campaigns. Now, it's hard to get people to turn out their lights, and especially if we're asking them to turn out their lights for weeks or months during spring migration and again during fall migration. But the radar studies show this. We don't have to have people turn out their lights for weeks or months at a time. In almost every major metropolitan area, the majority of migration occurs on just 4 or 5 nights in the spring and 4 or 5 nights in the fall. And we can predict when those nights are going to be. We've got the ability to do that. And so in many areas, Audubon chapters and other organizations are rolling out, you know, automated, sometimes AI-assisted alert systems to say, okay, Cleveland, tomorrow night, huge migration night, turn out your lights. Dallas, tomorrow night, turn out your lights. We can make a huge difference for birds on just a couple of nights during the spring and fall. But we also know that the birds are going to get drawn into urban areas anyway, just because there is so much light pollution out there. And we're coming to understand the degree to which tens to hundreds of millions of migratory birds depend on urban green spaces and parks. And these are places that we don't manage for birds. We manage them for human recreation. And there's no reason that there can't be room for both. And I think that it's been a belated realization on the part of many bird conservationists, and this has been a recent awakening for me as well, that we can get a really significant bang for our conservation bucks by improving, restoring, and expanding bird habitat in urban parks and other urban green spaces. In fact, it may be that that's a better use of some of our conservation dollars than protecting more pristine areas in more rural regions. We're also benefiting from an explosion in new tracking technology. And this is something, as I said earlier, that I've been privileged to be a part of over the last 25 years or so. For example, about 10 years ago, a bunch of colleagues of mine and I founded something called Project SNOWstorm. And you might want to grab a screenshot right now on your computer so you can save that web address. Project SNOWstorm, we study the winter movement ecology of snowy owls. And we do this by fitting snowy owls with what are known as GPS GSM transmitters. These things are about the size of a matchbox. They weigh about 45 grams or so, about 2 ounces, a little less than 2 ounces. They're solar powered. They operate using two technologies that most of you probably have in your pocket right now. They communicate with the GPS satellite system overhead and record latitude, longitude, altitude, and flight speed as frequently as every 6 seconds. And then they dial up through the cell phone network and they send us all of that data Sunday, Tuesday, and Thursday nights at 7:06 p.m. Eastern time. This evening here on the East Coast, my phone started buzzing and I got a bunch of text messages from 5 snowy owls that we're tracking this winter, thus proving that my friends are cooler than your friends because I get text messages from snowy owls. All the tracking data from the 113 snowy owls that we've tagged in 17 states and provinces across the US and Canada are available at Project SNOWstorm, including the tracking data from the 5 owls we're following this winter. The one thing we won't tell you is where the owl is right now. We time delay all of the data by about 24 hours to give the bird a little bit of cushion there, a little privacy. So that works really well. If you're using a 45-gram transmitter on a bird that weighs 5.5 to 6 pounds, there's a good chance that bird may not even notice that the transmitter's there. If you put a 45-gram transmitter on the back of a 30-gram Swainson's thrush, you will get no migration data at all. And in fact, until recently, it's been difficult or impossible to track most migratory birds, most of which are pretty small, across landscape or hemispheric or global distances. But that is changing thanks to something known as the Motus Wildlife Tracking System, MOTUS. It comes from the Latin word meaning movement. Motus was the brainchild of Birds Canada, which is kind of the Canadian equivalent of Audubon. And it uses two technologies that have been around for a long time, but it marries them in a new way. It uses automated receiver stations like the one you see here that basically look like somebody forgot to take down their television antenna, and tiny little VHF radio transmitters, all operating on the same frequency, but sending out individually unique coded ID pulses. And when I say little, I'm talking, these are fraction of a gram. Some of these transmitters are small enough not just to put on the smallest birds like hummingbirds, but on migratory, monarch butterflies and migratory dragonflies. And then they are tracked, as I said, with these receiver stations. And there is a rapidly growing network of Motus receiver stations. Now, I'm involved with something called the Northeast Motus Collaboration. It started about 6 or 7 years ago. A group of us based originally in Pennsylvania, we've built about 150 of these Motus receiver stations from Maryland and Delaware north into New England. We're finishing up this spring installing the last of our 50 New England stations. But as you can see, the Motus network is exploding across North America and increasingly throughout the world. And things are really on fire. Well, that's really in the West. That's a very bad thing to say. My apologies. But Motus is really there are so many people that recognize the value of this in tracking birds and bats and insects that we've never been able to track before. And here's the cool thing. If you go to the Motus website, and here again, you might want to grab a screenshot, motus.org, all of the tracking data from all of the 36,000 birds and bats and insects that have been tagged with Motus is publicly available. So for example, one of my former owl banding volunteers from my owl research projects in Pennsylvania, she's doing her PhD at Guelph University on eastern whippoorwills and common nighthawks. And you can see where all of Alora's nighthawks have been traveling. And in fact, I'll just go back to that map. All of those little yellow dots from the Motus website, those are all clickable. You just find the Motus station closest to your house and click on it, and you can see what's been going past there. You can create maps that show you where that organism has gone. It's really, it's amazing. It's also highly addictive. So give yourself a little time when you start playing around with it. But all of this information that we have at our fingertips that we didn't have even just a couple of years ago gives me hope that we are going to finally have the tools to start making smart conservation decisions and reversing the declines that we've been seeing in these migratory birds. And sometimes hope is the hardest thing to find. The challenges can seem so huge and so daunting. It's easy to give yourself over to despair sometimes. And that's why I want to leave you here with a final story that shows what can be accomplished for migratory birds in even parts of the world that to us seem impossibly remote and incredibly poor. And so I want to take you now to actually one of the more remote places I've ever traveled. These are the mountains of Nagaland in northeastern India. It's that little bit of India that sticks up like a thumb between China to the north and Myanmar, Burma to the south. Ruggedly mountainous, densely forested. And every year in late October and early November, at the end of the seasonal monsoon rains, millions and millions of Amur falcons come pouring into Nagaland from their breeding grounds in Siberia and China and Mongolia, en route to their wintering grounds in southern Africa. These guys are about the size of an American kestrel. They're largely insectivorous. And the reason that they're gathering in Nagaland at that time of the year is that at the end of the monsoon rains, trillions and trillions of winged, fertile adult termites emerge from underground and rise into the sky on their mating flight. So you have these big, fat, juicy bugs that are a perfect food for an insectivorous falcon that has an exceedingly long way to go, because these birds fly from Asia across 2,400 miles across the Indian Ocean, the longest overwater journey of any raptor on Earth to their wintering grounds in southern Africa, where they spend the winter feeding on emergent termites. 18,000 miles a year. It's arguably the longest migration of any raptor on Earth. And this enormous gathering of Amur falcons in Nagaland was unknown to those of us in the outside world until 10 years ago, the fall of 2012, when the woman on the right there, Bano Haralu, who is a native Naga conservationist, who had founded a small conservation and wildlife trust in Nagaland some years earlier. Bano had been hearing these rumors of these enormous numbers of falcons in a remote part of Nagaland, close to a village called Pangti. And she finally, in the fall of 2012, she and her colleagues there from Conservation India decided they were going to check it out. And so they went bumping on these just god-awful roads through central Nagaland, and they found the falcons. But what they found horrified them. They found that the villagers from Pangti and some of the surrounding communities were killing like 140,000 of these falcons every year at the peak of the migration for food. Now, not food for themselves. And here again, I want to stress, this was not a traditional subsistence hunt. They only started killing these falcons about 10 years earlier, when the Indian government built a ginormous hydroelectric dam that flooded out the farm field, the valley where they had their farm fields for time immemorial. And also, for reasons we don't really understand, these falcons, which had always been passing in large numbers through Nagaland, after the construction of the Doyang Reservoir, they began gathering in incredibly dense nighttime roosts in patches of forest along the edge of the reservoir, which made it really easy for the villagers to string nets in the trees and catch these birds and kill them and pluck them and smoke them and then sell them in larger communities for cash money, which they were using to pay their kids' boarding school fees. Because if you want your kid to get more than a third grade education in Pangti, you got to pay to send them to boarding school in a larger town or city. Well, as you can imagine, when word of this got out, there was international outrage and disgust, but also a great deal of concern. Amur falcons are common, but I mean, they're not that common. No raptor species has enough reproductive potential to put up with losing that percentage of its population every year without going into collapse very quickly. But that didn't happen. In fact, a really remarkable thing happened, in part because of increased law enforcement. This hunt had always been illegal, but the authorities had just always kind of turned a blind eye to it. But mostly because of a conservation education effort where Bono and other conservationists sat down with community leaders and religious leaders in Nagaland and explained to them what they were doing to these birds. If they continued to do this, these birds were going to disappear. And the Naga said, look, we didn't know. We'll stop. And they did completely from one year to the next. 140,000 dead falcons one year, virtually none the next year. And within a year or two, the world went from condemning them for their barbarity to praising them for their conservation leadership. In fact, many of the former falcon trappers formed what they call the Amur Falcon Roost Area Union to protect the roosts that they were once plundering. But here's the thing. One of the reasons that the Naga turned away from falcon trapping so quickly is because Bono and the other conservationists told them, look, this is one of the greatest wildlife spectacles on Earth. And it is. It really is. People are going to want to come to see this. Tourists are going to want to come to see this. You can make more money from tourism showing falcons than you can from killing falcons. But Nagaland is like the backside of beyond. It is not an easy place to get to. And by all accounts, tourists were pretty thin on the landscape. And I had to wonder, what happens when people who don't have a lot give up something that they have expecting a certain outcome? What happens when that outcome's a little slow to materialize? So in the fall of 2017, along with my good friend Kevin Laughlin from Wildside Nature Tours and a couple of good friends, including Catherine Hamilton from Southern California, who were willing to go along as guinea pigs, we headed to Nagaland to see whether it was possible to start bringing American tour groups in to try to provide some direct support for this sort of nascent conservation effort. And folks, I am here to tell you that this is not an easy place to get to by any stretch of the imagination. You see the main road before you, you see the main road into Pangti. That is an active landslide zone right there, where periodically the mountain just kind of gives way and takes everything along with it, including, God help you if you're the one on the road at the time. And oh, by the way, what you can't see is that slope goes for hundreds of feet further down the mountain outside of the frame of the picture. I have spent a lifetime traveling on really bad roads in remote parts of the world, but I don't think I've ever been quite as terrified as I was on the roads going into Pangti. It just got awful. And we were also told repeatedly, don't be on the road after dark because of the danger of armed bandits and cross-border Maoist guerrillas coming in from Myanmar. Because did I mention that Nagaland is the site of the longest running guerrilla war in Asia? It's been going on for about 80 years. But I got to tell you, it's worth it. I've spent my career chasing some of the biggest raptor concentrations on the planet. I was part of the team that first documented the huge raptor migration in eastern Veracruz in Mexico. But I have never seen anything quite like the concentration of Amur falcons in Nagaland. These birds are there for weeks by the millions. And each of these roosts, you look up and there's 50, 60, 100,000 falcons rising up into the air, these great reverse tornadoes of birds. And this is just one roost. I mean, you look up and down the Doyang River Valley in the morning, and you just see columns of birds pouring up into the air. And then they spread out during the day. They feed on the termites. They're filling their gas tanks for that tremendous flight across the Indian Ocean, and they come pouring back in at night. It really is an amazing thing to see and even to hear, because we would go out before daybreak in the morning and you just hear this rushing sound of high winds, or it sounds like a waterfall overhead, and that's just what the wings of tens of thousands of falcons sounds like in the pre-dawn darkness. As I said, one of the things I was interested in is what happens when people make a hard choice expecting a certain outcome. At the peak of the falcon hunt, pretty much everybody in Pangti benefited economically from the falcon kill. There's about 500 households in the village, and everybody had a hand in the falcon hunt, and everybody benefited to some degree. As I said, many of these families, maybe even most of the families, were using the money to pay their their kids' school fees. Now, for some of the former trappers, like Nchomo Adoyu, they were able to pivot to guiding. Nchomo, even though he does not own a pair of binoculars, is one of the most amazing bird guides I've ever had the opportunity to be in the field with. And the money Nchomo makes from guiding has essentially replaced the income that he gave up from hunting falcons, paying for his wife and kids that are still living at home. And at the time, he had 3 kids in boarding school that he was paying their fees for in the city. Members of his extended family own some of the land where some of the biggest roost sites occur. They built a watchtower, charge a small nominal fee to use that. Some of the families in the community had enough wherewithal to install Western style toilets in their house, not flush toilets exactly, but nevertheless not a squat pit. And so they're able to rent their homes out as homestays. But at the moment, there's not a great deal of equity in how the benefits, the economic benefits of falcon tourism are being spread in the communities. But I will tell you that the falcons have sparked a real booming interest in conservation in general. Bird watching is becoming more and more of a thing in Nagaland. And as you can imagine, the pandemic has really put a crimp in international tourism. But as many of you know, India has a really robust domestic birding community and a lot of really avid bird photographers, and more domestic Indian eco-tourists are coming to Nagaland every year. In fact, to the point now where a number of communities are fighting with Pangti for the title of the world's falcon capital. I've got to tell you that what the communities of Nagaland accomplished for Amur falcons ranks as one of the most amazing conservation success stories I've ever had the chance to report on. At least here, at least for now, at least for this one precious species, the world's a little bit safer. And they're all precious. Every bird that makes that leap into the void is at once utterly ordinary and extraordinary, shaped by millions of generations of natural selection, crossing immensities of space that we can barely comprehend, through dangers that we hardly understand, and doing it all for eons on the strength of their own muscles and the tenacity of their own wings. And that's always been enough, but not anymore. Now, for better or worse, their fate is in our hands. And I hope and pray that we're up to the challenge. Folks, I want to thank you very much. It's been a pleasure. I'm going to take a drink of water, stop screen sharing, and then happy to answer any questions that anybody has.
Right. Well, so just a reminder that if you have questions, please put them into chat, and we appreciate if you share them with everyone so that other people can see the questions as well. We've got a few from earlier on that I want to make sure we don't miss. The first question that came in was actually about avian flu and bird feeding.
So this highly pathogenic avian influenza that's been in North America since January of last year has a lot of us very concerned. Its impact on particularly on water birds, seabirds, waterfowl, and raptors that feed on them, like snowy owls and bald eagles and golden eagles. I think we're looking potentially at population level impacts on those birds. Fortunately, it really does not appear to be much of a problem for feeder birds. It really has at least so far, has not been a significant issue for passerine birds. And so none of the guidance that I've seen from the National Wildlife Health Center and places like that have been recommending that people do anything other than the usual, cleanliness and hygiene things that we should all be doing with our bird feeders anyway, which is every couple of weeks, emptying out your feeders, cleaning them, dilute bleach solution, things like that. But I don't think at this point there's no indication that we have to worry about HPAI, highly pathogenic avian influenza, being a problem for backyard bird feeding.
Let's see. Where'd it go? There was another question about, which I think you may have really answered as well as we can at this point, was about the changes in, I can't find it now. About the impacts of climate change. I feel like you touched on that. I don't know if there's more that.
Well, yeah, I mean, look, I touched a little bit on kind of the phenology issue and the timing issue, but the fact is climate change is affecting every moment of a migratory bird's annual cycle, from the breeding grounds to the wintering grounds. The folks at Cornell have been doing some modeling on how under different climate change regimes, weather patterns and particularly wind intensity may change at different times of the year. Because of course, so much of bird migration is tied to predictable weather and wind patterns. The reason a bar-tailed godwit can fly across the Pacific Ocean is because there are low pressure and high pressure systems that it can hitchhike on at different points of its migration. Those semi-palmated sandpipers and blackpoll warblers and mourning warblers and other birds that are flying out over the Western Atlantic they can take northwesterly winds as they leave land flying out over the Atlantic, and then they can eventually pick up the northeasterly trade winds that will carry them as a tailwind back in towards South America. So, as climate changes, as weather changes, we're not really sure how that's going to affect birds at different times in their life cycle. Cornell's been modeling some of this stuff, and they're finding that wind and weather conditions may improve at certain times of the year for birds and become much harder and more of a headwind for them at other times of the year. So it's a real mixed bag for them.
We had another question about wind turbines. I think is an interesting and challenging issue.
Was there a specific question or just sort of a general?
The question was, what about them?
Wind turbines sometimes kill birds. They also sometimes kill bats. Location. There are some places that are less appropriate for wind turbines than others. I'm kind of terrified that the Canadian government is pushing to put huge numbers of wind turbines out in the middle of Lake Erie and Lake Ontario in, right in the path of many birds that are flying up through the central part of North America, and often crossing those lakes at relatively low altitudes, including a lot of the snowy owls that we track. They're flying right across the lake, right at that turbine height. On the other hand, we squandered the last 40 years when we should have been doing something about climate change, and we didn't. And now the world is on fire. And we're kind of at a point where we got to throw everything we have at it. And so I don't know that we in the bird community can be all that fussy about this, because, as I said, climate change is altering absolutely everything about migratory birds and the environment in which they live, the food resources that they depend on, and that's only going to accelerate. So, I think it's important for us not to have kind of a NIMBY attitude, or maybe, don't mess with my taxa approach. But I also think that there needs to be a significant amount of research before we start building turbines. Like, for example, we're going to start building a lot of turbines offshore, put them as far offshore as we can, away from the site of land, so people don't have to look at them. And we don't really have a good sense of how that's going to affect, for example, pelagic seabirds and birds that are migrating long distances offshore. One of the ways that the Motus wildlife tracking system is being used for right now here on the East Coast, they are putting Motus stations out on experimental wind turbines and buoys way out in the Western Atlantic and the Gulf of Maine, places like that, just to try to figure out what's flying out there, because we don't have radar coverage out there. We don't really have a good sense of what's out there and where they're going.
I would say that's my answer is generally, we need to know a lot more about how birds are using our landscapes.
Yes.
And we have the tools today. We just need to use them. We need to find the funding to make it so that we know where they are and what they're doing.
Well, and quite frankly, we should be requiring wind developers to underwrite that research, because unfortunately it has tended to be, too little, too late. It's usually what's described as pre-construction monitoring, which presupposes there's going to be construction. I have, maybe it's happened, but I've never really heard of anybody doing that kind of pre-construction monitoring and going, oh God, we can't possibly put up a turbine here, there's too many birds. That almost never seems to happen.
Oh, here's a great way. Maybe we could take a few more questions, but this is a great ending question, but maybe we're not quite ready there. But there's one thing that we can do as individuals to support bird populations. What would it be?
Well, you gotta keep me down to just one. I've usually got like 5 that I can tick off right off that are
all right,
simple.
3. Okay.
All right. Well, okay. So, one of the most important is vote birds. I don't care if you're an R. I don't care if you're a D. I don't care if you're an I. I don't care what you are. Vote birds. Because what's good for birds is good for people, frankly. If you're a gardener, garden with native plants, be organic while you're gardening. If you have a cat, keep your cat inside, because my God, cats kill tons and tons of birds, and that's simple to fix. If you're a coffee drinker, seek out and drink Smithsonian migratory bird certified bird-friendly coffee, because it's a great way of preserving migratory bird habitat for neotropical migrants in Latin America and the Caribbean. And I think I went over 3. Sorry. But those are all simple things. I mean, we don't have to, reinvent the wheel here. All of those, they're simple, but at scale across millions of people that can make a huge difference.
A question about the Amur falcons. Are they also sought for falconry?
No, because they're bug hawks, basically. And that's not to say that nobody ever uses them. I mean, some American falconers will fly American kestrels, and they're not because they want to eat mice and grasshoppers, but no, they're a very small, delicate falcon, and they really do feed much more so than kestrels. They're much more insectivorous, so they're not really used for falconry.
So Scott, on your comment about voting, I just want to share. I have a hat I really love to wear, and it says, "I bird,
Yes.
I vote."
Amen. and make it a point of letting your elected representatives know that that's important for you. I mean, look, I talked at the beginning about the impact that we made for wetland birds and through wetland conservation in the 1980s and in the years since then. And that's because waterfowl have a hugely politically important constituency in the form of waterfowl hunters who are not afraid. And I speak here as somebody who at one time in my life was a really avid waterfowl hunter. I just don't get the chance to do it anymore. But, you know, these are people who are not afraid to let their representatives know, you know, I'm a duck hunter and I vote, and you need to take care of wetlands. You need to pass these regulations. You need to make the resources available. And we just need to let folks know how important it is to us. Our elected representatives need to know what birds mean to us.
Sure. Well, I have one question. It's probably not quick, but if there's time, do you see any specific species migratory issues in California that we should be paying special attention to? And if so, what do you think we can do to help?
I wish I were a little bit more deeply attuned to what's going on in California. You know, the thing actually, and this is not California, but the Western migratory bird issue that has me most concerned right now is the fact that we're a couple of years away from the Great Salt Lake drying up and blowing away. And, you know, when you look at like the global population of eared grebes depends on, you know, to a large extent on the Great Salt Lake, including a lot of eared grebes that are spent at other parts of the year in California. I wish I felt a little bit more optimistic, but it seems like the state of Utah is just bound and determined to destroy that place for the sake of sucking a little bit more water out for a few more housing developments. And they're gonna wish they hadn't when they start getting, you know, toxin-laden clouds of arsenic rich dust blowing over Salt Lake City. You know, look, water in the West, I don't have to tell anybody here, is a difficult issue. I mean, it's been a relief to see California getting a little bit more rain this year, although hard to see what all of that rain has done to many people's properties. But, you know, water management across the West is going to be a hugely important issue in the coming years, not just for people, but for birds.
Mm-hmm.
There are a couple of other questions from the chat. One, I think the answer is yes, but the question is, did I understand correctly that though they may know to migrate earlier, climate changes may be negatively impacting food at either end? So the fact that climate change is throwing things out of whack for migration may also be throwing off their breeding and growth cycles.
Yeah, that's absolutely right. Because what happened, like I said, you get this phenological mismatch where you know, these insect-eating birds are coming back, trying to catch this you know, sharp seasonal peak in insect numbers in the weeks after, particularly after hardwood forests have just leafed out. And you know, if they miss that, you know, the average small songbird, you know, they're feeding their chicks something like 6,000 caterpillars over the course of 10 days. And that's a lot of work. That's a lot of food to find. And if you miss the peak and you can't get that much food, your babies just don't make it. And that's what happened to pied flycatchers starting in the mid 80s in Europe, where, you know, that critical early spring period in late April and early May began to warm dramatically faster, and it left these birds farther and farther and farther and farther behind, and their populations in some cases dropped by like 90%. Now, the thing is, more recently, in the last 10 years, that rapid warming during that critical period in spring slowed in parts of Western and Central Europe. Not because climate change stopped, but just because, you know, that anomalous rapid warming slowed for, you know, reasons that we don't really fully understand. But it gave the pied flycatchers a chance to catch up. And I spoke last year for an article I did for Audubon magazine with Dr. Christian Both in the Netherlands, who's the person who, you know, really brought this whole pied flycatcher phenological mismatch situation to the fore back in the 90s. And he and his students were able to show not just that the birds caught up, but they caught up because they had actually evolved an earlier arrival time. You know, we underestimate the resiliency of birds, I think, at our peril. They're astoundingly adaptable if we just give them a little bit of a chance. And that's that resiliency of birds that has surprised us so often in the past. I put a lot of hope in that. We're making progress on the climate change front. The predictions, the sort of the worst case predictions today are less dire than they were just 10 years ago. They're still pretty bad, but they're better than they were, and we're going in the right direction. And I hope that we can pull this out of the fire for ourselves and for the birds.
There's a series of questions. I think somebody did a little research on Motus stations and noticed that there weren't any in San Francisco. There are Motus stations in Tiburon, Berkeley, and there's one at the San Francisco Bay Bird Observatory at Coyote Creek, which is, I guess, in Santa Clara, I think. Correct me if I'm wrong, Matthew.
Yes.
But hey, they're fairly easy to put up. They're relatively inexpensive. Those receiver stations, in terms of parts, probably cost about $4,000 to $6,000. I mean, we're not talking huge money here. Anybody with a little bit of electronics experience and a little bit of basic construction experience can put one of these things up. And that's happening increasingly. I mean, schools are putting them up, nature centers are putting them up. It's really cool to be able to show people what's migrating literally over their heads that they're not familiar with. It's been a very cool project. Back in 2012, my colleague Dave Brinker and I were among the first people to start using this nanotag technology to we're looking at sort of regional movements of saw-whet owls in Pennsylvania. And then when we heard what Birds Canada was proposing, they're kind of building this thing out, we thought, this is amazing. We got to get involved with this. And it's been amazing to see it just kind of explode around the world.
Yeah, the South Bay project, I believe, is an SFBBO project.
Oh, super.
I have a question. I read an article recently in Bay Nature that talked about how some birds, unlike on the East Coast, where birds are arriving earlier to match up with the spring leaf out, that in some instances, Wilson's warbler in particular, are arriving later.
Yep.
On the West Coast. Talk about that.
There's been some. It's the signal is a bit less clear in parts of the West. And had a fascinating conversation with Morgan Tingley, who's been doing a lot of work on phenology out west. I'd done that sort of redid the Grinnell work from 100 years ago. And his point to me was that what complicates things in the West is its temperature and elevation and precipitation. In some cases, because precipitation timing and amount is changing, that the birds are shifting to catch that. So it's not quite as straightforward as it is, say in the upper Midwest and parts of the East. But that's nature is complicated, and birds are complex, and vary from one species to another. Each species of bird, even within wood warblers, every species of wood warbler has different needs. They're coming from different places. Different regional populations and different regional breeding populations of different regional wintering areas, that migratory connectivity that scientists are increasingly exploring. I see what's Maureen saying, that Morgan's going to be a speaker. I gotta tune in for that one in the fall. Yes, I will sign up for that one. Morgan's lab is doing some really terrific work. But it's complex. There's it's not one size fits all.
It's kind of fractal in a way.
Yes, that's a good way of putting it.
Well, we're nearing our witching hour here, which it's a little early for us, actually. I'm quite
well. I wanted to thank you, by the way. I meant to do that at the beginning, to thank you for doing this early on behalf of some poor schmuck stuck in the Eastern time zone.
Yeah. But thank you, Scott, so much for spending the evening with us. It's been fantastic. I think I've been seeing dozens of thank yous from participants in the chat.
That's very kind.
If you missed any portion of this, we will be posting it to our website, and I think Santa Clara will probably repost it for a few weeks after today. It'll probably go up tomorrow afternoon.
Hmm.
It will be available for a few weeks. So if you didn't catch something, if you your computer, fritzed out on you in the middle, you have an opportunity for the next few weeks to catch it again. We look forward to, please, if you're not a Golden Gate Audubon member, or if you're not a Santa Clara Valley Audubon, or if you're not about Diablo Audubon, or go down the list, check out our websites, because there's a ton of fantastic programming going on at all of these chapters. We have 9 chapters in the Bay Area, and each one does amazing work in their area. So please, if you're, you should, go ahead, join several of them. Why not?
Right. Great way to help birds.
Exactly.
Yeah.
And it's a great opportunity to learn. There's field trips, there's classes, there's lectures, and this is a tremendous resource that we have in our community. So please join us and share in the learning and the action. We'll be having an advocacy day in the spring or summer, so you can join us for that if you want to go make a difference up in Sacramento. I almost said a difference up in Albany. My New York days are a little hard to escape. But thank you, Scott. Thank you, Matthew. Thank you for all of you for joining us today. We had great participation today, and look forward to seeing you all in the field or at our next lecture.
Thank you, everybody. Thank you, Scott. Thank you, Glenn. Wonderful presentation. So glad.
It was my pleasure. Thank you so much. Really appreciate it. Good night, everybody.
Good night, everybody.